In this next chapter, we get into a bit more of the day-to-day detail of IT operations in practice and what risks that brings, and in particular what controls you'd expect to see in place in order to manage those risks. Now, the controls you'd expect to see in place over information IT systems are divided into 5 categories for the purpose of this syllabus. Firstly, you have controls over systems development. So when a company or an organization needs a new system, that is an area of very high risk. All sorts of things can go wrong, whether it's with the design, with the actual development or coding, or the implementation itself. So you need to have some controls in place. This is a very commonly examined area, so you need to be familiar with it. It will help if you remember from E1 things like the systems development life cycle, but we will recap that in this course. Second area of controls are general controls, and they apply to all the systems that the organization uses. So an example of this, an example of controls applying to all systems, would be something like access controls, because you need to make sure, whatever the system is, that the only people who can access it are those who are authorized to do so. And the most common control is passwords, but there's some good practice around passwords, around changing them, using things that are hard to remember and so on, that it's worth being aware of. The third category of risk are application controls, and these are controls for a specific application or a specific piece of software. So it's quite hard to generalize about this. It's going to be very much driven by what the system actually is. All I can say is that the scenario in an exam will give you some clues here, and it'll be a matter of picking up the clues as to perhaps what might be wrong, what controls you need, and maybe some issues with the existing controls. Fourthly, we have controls over the use of unauthorized software. Unauthorized software carries a lot of risks in terms of things like corruption of data or carrying viruses. It's also illegal, can open up an organization to fines, so we need some controls there. And then finally we have network controls. So network controls is when computers are connected externally, which pretty much they all are nowadays, to an internal work system and usually to the internet as well. Now this makes them far more powerful, but it also opens up a whole new area of risk, particularly around things like viruses and hacking, so again some controls are needed there. So what we're going to do in this chapter, we'll work through these 5 categories in turn. Now when we think about risks relating to IT, in the previous chapter, we focused on risks at a more strategic level, the risk of having information that is inappropriate, the risk of having the wrong IT strategy. However, a lot of risks relate to information operations, in other words, the day-to-day running of your information systems. And that's what we're going to focus on in this chapter. So before going into the controls, have a go at brainstorming as many operational risks to information systems as you can think of. So in terms of the day-to-day running of information systems, what do you think could go wrong? What are the risks you'd be concerned about? Press pause, and then press play when you're ready to debrief this. Okay, so what sort of operational risks to information systems should we be concerned about? Well, there are many, but they include physical damage. Most organizations have a lot of very valuable information stored on their IT systems, and if they are damaged, for example by fire or bomb or sabotage or something like that, then that information could be lost, and that would be extremely serious. It could be human error in processing, so maybe things go wrong with your information system just because people get it wrong and make a mistake. Or it could be that it's not actually an error, it's fraud. Computer systems do offer lots of opportunities for fraud because they can be complex and they can involve specialist knowledge. I think we're all aware nowadays that viruses pose a threat to information systems. Viruses can come in through emails, through computer sticks, through all kinds of methods, and once they're in a system, they can cause a lot of damage. There may be compliance risks, and in the UK, the particular issue is going to be the Data Protection Act. The Data Protection Act requires that any personal data is held for a specific purpose, used only for that purpose, and is kept secure. So organisations that don't do this can face fines and reputational damage. Many other countries do have similar legislation in place. There's a risk of use of unauthorised software. As we'll see, there are many risks involved in using illegal copies of software. And there may be risks involved in system development. It may be that systems are developed that are not fit for purpose. They don't function as they should. And we could go on. But you get the idea that at the day-to-day operational level, there are lots and lots of things that could go wrong. And this has been the focus of a number of exam questions in the past. So how do we control these risks? Well, before we get into the technical detail, it's important not to lose sight of the big picture here. Throughout this course, we've emphasized that there are three types of control over pretty much any risk you can think of. Remember, we have controls over input, generally your HR controls. We have controls over process, which is to do with procedures, doing things in a certain way. And we have controls over output, which takes the form of measurement. Now, IT is no different to any other area in this respect. You can think about it in terms of input, process, and output controls. So what would be the input or HR controls relating to IT? Well, mostly they revolve around the IT function, and this is why we focus so much on the management of the IT function in the previous chapter. One of the ways you can control these risks is to make sure that you are recruiting the right people into your IT function, that it is staffed effectively, you're investing enough in it, you're giving them adequate training, good motivation, generally making sure that your IT function is doing the best job they possibly can. That's one approach and one element of IT control. The second type of approach relates to process or procedures, and IT departments very often have many procedures that they carry out regularly in order to reduce risk. So an example might be daily backup of important information. So every day you download the important information, copy it over into some sort of external hard drive or backup facility, and make sure that is stored off-site so that if anything happens to your main center, you haven't lost the data. Procedures may also include changing passwords. Passwords are a very, very common type of control over IT security, and many organizations require that their employees change them perhaps every 6 weeks or so. That is a procedure that can be put in place to reduce risk. And then finally, you can think about measures relating to IT control. So what could you measure that would help you to manage risk? Well, an example might be downtime. How often does your IT system go down, and how long does it take to get it back up? If you can keep that measure down to an acceptable level, you are reducing risk. It may be the number of exceptions in a particular process. Again, you're trying to keep that number as low as possible, and that way reducing risk. So we're going to talk about some specifics here, but please do keep in mind this is just like any other risk, and you can think of it in terms of your input, your process, and your output. Now, the specific areas that you need to be aware of are, firstly, controls over systems development. So organizations very often will develop new systems. They'll put new systems in place to respond to changing needs. That brings its own risks, and there are controls you can put in place to reduce those risks. There are general controls, which are over your systems as a whole. For example, access controls apply to all your systems. They would fall into the category of general controls. There are application controls that apply to an individual application. And if you are required to do this in the exam, you will be given some clues in the description of the application as to what sort of controls would be appropriate. There are controls over software to make sure that software is authorized, because there are some significant risks relating to the use of unauthorized software.
And finally, network controls are relevant to distributed processing. So most computers nowadays are networked over the internet or internal corporate networks, bringing a lot of capability and a lot of power, but also additional risks. Again, we'll look at how you can control those risks.
One area that's examined quite heavily in this paper are the risks and controls around systems development. So if you're actually building or buying a new system for implementation in your organization, that is a key area of risk, and there are certain controls you need to have in place. Now, there's quite a lot of assumed knowledge in this section, because you covered the systems development life cycle and some issues relating to things like testing in E1, and you also cover project management in E2, and a lot of the techniques and issues of project management are very, very relevant here. So some of what we go through you will have seen before, but it's important to recap it so you have a good understanding of it for this paper. So we'll start by recapping the systems development life cycle, which is one of the models that tells you about the different stages you tend to go through in putting a new system in place. So the SDLC says that you start with a feasibility study, and this is when you review the existing system, you look at what you've got in place already, and you start to think at a very high level about alternatives. So what sort of system do you need? What sort of things need to be different? You then need to get into a bit more detail and investigate the system, and in particular, here you are investigating the detail of user requirements. Remember, these things all need to be driven by the users. Too often, these sorts of projects are driven by the IT function, thinking about what would be a good thing to do. It's really all got to come down to the users. How do they work? What do they need the system to do? What you'll also do at this stage is you'll look at the current problems and issues. If you're looking at a systems upgrade, then presumably there are some current issues. What are they? What are the problems? You then go into the detailed systems analysis. You look at why you're using the current methods. Presumably there is a reason. And you're looking in detail at what are the better alternatives. So how could things be done differently at a very detailed level? Next stage is systems design, and this is where you get into what is the new system going to look like. Do things like the specification. And you also consider security. So how is the system going to be secured? How are you going to make sure no one unauthorized can get in or data can't become corrupt? You've then got systems implementation, which is where you actually get on with it. You either write or acquire the software. And you put it in place. So that might mean all sorts of things. It might mean buying new hardware, it might mean installing hardware, it might mean transferring data. This is where you actually put the new system in place. And the whole thing doesn't end there, because then there's ongoing review and maintenance. Check basically that it's fit for purpose. So you need to regularly review, is the system fit for purpose? If not, do you need an upgrade? Do you need to do something about it? So that's just the overview of how systems development can work. There are other models as well, but this is one way of thinking about the different stages involved. Now, there are certain controls that need to operate at a macro level. Remember, in this paper, what we're mostly interested in are the risks involved in this process and what controls you'd expect to see in place. Now, a big project like this, you would expect to see some overall controls, such as having a steering committee in place. It needs to be taken seriously. This is probably something that's very important for the business and involving a lot of money. So it needs to be overseen by a steering committee that will generally include people like the project sponsor. The project sponsor, remember, is the person who makes resources available. So for a big project, it might be the chief executive, it might be the finance director, it might perhaps be the IT director. You'd want the project manager to be on the steering committee so they can explain to the others what's going on and what the status is. You will want people who are specialists in IT, who are very familiar with what technology can do and what the technology issues are likely to be. But you also need users as well. You need the users throughout the project to be giving their input and checking that everything is as they need it to be. You might want to put internal audit there as well. You might want internal audit to be effectively doing a continual audit on the project, checking that everything is on course and that there are no particular control issues arising. It really helps, as for any major project, if you have a proper project team, everyone knows they're on the project team, maybe seconded onto it full time if it's very resource intensive. So you've got the right people, you've got the right expertise, you've got people who know about IT, people who know about project management, and the right terms of reference so they know what they're doing. It may sound obvious, but quite often projects run into difficulties because there's some disagreement perhaps about what the project is really there for, maybe what the scope of the system is. You would expect to have, for a project like this, design criteria. So right up front it should be very clear what the policy is and what the standards are in relation to, for example, data security. So people will think right at the start about how is the data going to be kept secure, what are the levels of authorization going to be for changes or for inputs, and when do you consider the design to be accepted. So who needs to sign off to say that, yes, we're happy with the design? Clearly the steering committee will need to sign off, but it may be that other groups will as well. You would also expect to see involvement of the board of directors for the high-level decisions. So the board itself really needs to be involved in approving the objectives of the project and making sure that things are on track throughout, making sure that the spend is on track, making sure that the timelines are not slipping. The board themselves need to get involved here. There needs to be clear and realistic budget. Again, key problem with a lot of IT projects is that they don't have enough budget in place, and therefore they go over and that causes problems, and that they have proper personnel. They know who they have, they've got the right skills, and they've got enough time to deal with it. And you would expect to have, in the overall control framework for a large IT project, some ongoing monitoring of risks. So regularly the team need to be reviewing what could go wrong and how are we dealing with those risks. You will also want to have in place a testing strategy. So testing needs to be carried out at every stage of the project. You need to make sure the system works as it should do, make sure that any problems are flagged up early when they can still be fixed. So this isn't just something you do when you feel like it. You plan what tests you're going to carry out. This should be planned right from the start. They need to be carried out, and they also need to be documented so that auditors or anyone else who's interested can check what testing has been done and actually make sure it's been carried out in accordance with the strategy. This next lecture example shows you the sort of way you might need to think about an exam question. So it's likely that if you have a scenario involving systems development, there probably is a testing strategy in place. There probably is testing being carried out, and yet there might still be errors. So have a think about why. Have a think about why, despite there being a testing,